we had we had to wait on this Nate McLain guy to show up to the
Hey,
podcast
we were waiting
anyway.
on you
So
today, so turnabout's fair play,
Oh
buddy.
my gosh. How long did we have to wait for him? Like an hour? And then he showed up and he
I don't
left.
know.
Yeah, I
I
just
don't know.
abruptly hung up. I said, screw these guys. I'm out of here.
Yeah, just bails out on us.
You're listening to the Foundry Talk podcast with your hosts, Nate McLain and Perry Merritt. Take it away, boys.
Well, welcome back. My name is Perry. This is episode something or another of Foundry Talk podcast. With me, as always, is my partner, Nate. Hopefully, Nate will control himself. He's not uber caffeinated today, so we're hoping to see a nice subdued Nate. We are honored to have with us Todd Yoder. He is the Additive Manufacturing Manager at Hoosier Patterns. Todd is responsible for essentially 3D printed molds, and a fascinating piece of technology, if you ask me. And I'm looking forward to hearing more about it. But Todd, I thought the first thing I wanted to ask you about is your website. And you guys have got a pretty cool website, actually. You, in the respect that you spotlight, or you have videos up for, is it all your employees or a number of your employees anyway? And I just thought that was the coolest thing. What prompted you guys to do that?
Well, a couple of years ago, we really got big into marketing and put a lot of work into the website itself. The owner of the company is, it's a smaller company. We're probably pushing close to, I don't know, 65 or 70 people, but it's still kind of has the family feel. And so when we redid the website, the owner of the company was pretty adamant that he wanted, to get everybody on there. So, that they know that we are all Hoosier Pattern. This is what makes up Hoosier Pattern. And so it gives us a chance to, showcase everybody, show everybody's important here. It's not just one or two people. So, when you go to our website and you look at the About Us page, we want you to see the team and what we stand for. So it's been fun. It's a little bit of a challenge to get everybody to update or to put stuff in for their bio or to bring personal pictures and stuff. But it definitely makes a neat feature to our website.
Okay. Yeah, and Nate, you said you were going to even try to attempt to do something like that at your place.
Yeah. We're gonna incorporate that. I mean, I think it's brilliant to let the team know that hey, without the team and those individuals, their bio is super important to KN Manufacturing, and even Kansas Castings for that matter. You visit with Matt about that, and because we have our website working on now. But I mean, to capture that because they are the Foundry. Without them, Nate and Kelly at KN Manufacturing, we're nothing without our associates and our teammates. So we can't do it without them. It's definitely a team effort. So we're definitely going to steal that. I'm not apologizing for it at all. So tell Keith, hey, it's going to be on our website as well. And I think it's a brilliant idea.
Well, we had a meeting with our internet, our web designer here a week or two ago, and found it interesting that he said that one of the when they go and look at traffic across our website, the most traffic of any of the pages is our About Us page, where people are going in to see the people. So thought that was kind of interesting, and it's neat too.
What does that do for just the employees themselves? How does it affect their morale and their, I don't know, I would even call it a sense of belonging, sense of family at Hoosier Pattern?
Well, I would think it's the sense of belonging. They can go on the website and they can show their family and friends. Hey, this is who we are. This is who I work with. And I think it kind of helps them understand that they have a part in this whole thing and the whole team. They're important too. They have a face to Hoosier Pattern, so they're not being looked at as not valuable. So
When you guys onboard, when you onboard somebody, a new person, is that one of the things they have to do is like put up a profile for the site?
Yes, yeah, that's something that we ask them to do. And there's the probationary period,
No.
but shortly after that, we ask for bios and pictures if they're willing to put a picture up, and we add that to the website and try to keep that up to date. So it's it's a neat thing. It really is. And yes, it's some people like to keep their home life, their private life private, but it's still, if you can share a little bit of tidbit of information about yourself, that it's more personal, and I think it connects to more people. So
Yeah.
Absolutely.
Yeah. I thought it was pretty cool. You don't see that very often, and certainly not the world I came out of.
Well, not even that, but it's
But
very well done. It's very professional. I mean, the videos and stuff are good quality. They're not crappy, pixelated videos and
yeah.
things. So they whoever did it did a good job. So pass that along to them for sure.
yeah, we'll do. Yeah, that the videos are fun too, because we have the not only this employee spotlight videos, which we haven't done one of those in a little while, so I'm sure we'll probably start adding more of those to the website. But we have training videos. We have videos on the different departments and what we do. Um, we have videos on the annual iron pour, which we have another one coming up here in a few weeks. But it helps people, the community, see who we are. Um, I found it interesting. This has been quite a few years ago, or shortly after I started here. Not a lot of people have heard of Hoosier Pattern, or if they have no idea what we do. And the owner, Keith Gerber, made it a point to have a open house one day, just in the middle of the day. And so we had a lot of people from the community come in and check out the plant. And that was the first time that anybody had been in there or anybody had any idea what we did. And lots of good comments, lots of a great response back, because people came in and saw how clean the shop was and were impressed, and we're impressed with the machines that we had. We may have only had one or two printers at that time, but still, people aren't used to seeing that kind of stuff. So it was a neat
Yeah.
event to get the community in here and see what we actually do.
So when I cyber stalked you, I did a Google map and drove around, and you guys are like right next to a residential area. I mean, like literally across the street, right?
Yep. Yeah, we have houses just to the west of us and just to the south of us. And then um, there's a kind of an open lot directly south or whatever. And then we have some train tracks. And then there's more houses, a block or so to the east. But yeah, we're kind of right in a residential area. So, we do everything that we can to, play nice with the neighbors. We want to be respectful of the fact that this is where they live. So when we're driving down the street, we want to be careful. Watching for kids that are out playing, not be overly noisy or not speeding and stuff like that. Um, we're not the plant itself isn't loud, so we're not making a lot of noise, but. I do feel kind of bad because we do have a lot of semi trucks coming in and out of here,
Sure.
so that's one of the things
Well,
that we have to deal with. But I think all in all, we have a pretty good relationship with the neighbors.
So I mean, with having the involvement with the community and stuff, I think it's super important. Matter of fact, funny that you say that, because I sent an email to our team this morning about, hey, 2026 is going to look a lot different than it does in 2025, because we're going to start an annual golf outing for our customers and their families to come and have an annual plant tour and things of that nature, where they can actually see some parts being poured. We're going to do Foundry in a Box, where some of their kids can actually make a mold and pour a casting to take home with them, and things like that. Bounce houses in the parking lot and stuff like that. That gets them involved and gets them connected to a relationship with us as one of their vendors and one of their key vendors, because we want them to feel like they're an extension of their business, and they own a foundry, but they don't have to deal with the nuances of all the difficulties of running a foundry. So I think it's really important, that a lot of those guys will, just depends on your vendors and that sort of thing. A lot of them are local to us, so it's not a big deal for them to come in and play golf and have a little golf tournament and give away prizes and build that relationship with those people. So the other thing that it does, which is probably not that building relationships with customers isn't important, but the letting the community know that, hey, there's a viable place that they can go work. You can actually have a
Yep.
career. You can become an apprentice pattern maker. There's all this cool technology. They're printing 3D printing sand in here, and to know that that's there. A lot of people would drive by and have no clue. People that live next door, if you didn't open it to them, they wouldn't have any idea that even exists. So I think that's really key to be able to capture some of those people, because Todd, I started as a pattern maker, and to find people that have the competency that can actually think like a pattern maker and want to stick with it over time and actually become apprentice pattern maker, that is very few and far in between. It doesn't happen often. So knowing, people
Yep.
you can plug those people into those things, and then also using other tools like the Gallup Strength Finder assessment and that sort of thing that I've mentioned before in the podcast, and we're going to get Wessel Watt on here so that he can actually explain some of that, because I think a lot of companies out there to be able to find the strengths of their individuals that hey, have your team. You already have a team, right, of 60, 70, 80 people already there. Well, you already know what some of their strengths are. I think it's super important to be able to hire a new hire, and they have the strengths that actually fit the bill for, let's say, additive, or somebody that has the ability to do a certain job. Let's say that they're hand finishing pattern tooling, or a match plate or something that's coming off, that they have some burrs and things like that. It takes a certain person to actually be able to clean a sand mold out to ship it cleaned already, right? Not everybody can do that, because some people would just drive them crazy. It's like, oh, no way in heck, I got to do that for how many hours and all day, and I got to come back here tomorrow, and I still have to clean sand. Some people would just drive them crazy. So knowing what their strengths are, you already have a team in place that do real well at those positions, and sometimes you need more people. Maybe you need to do a second shift. And I'm not saying just Hoosier, but I'm talking about KN. I'm talking about other foundries that are out there using those tools that a lot of people don't even know about. I didn't know about it until I was talking to Wessel about something else, and he was like, you know what? Because I was telling him I need to find an assessment where I can, because I get tired of hiring people. I have to hire 10 people to find one, and it's such a waste of resources and time. And you guys have a good pool of people already that you already have plugged in, right? So all you got to do is have them take the assessment, figure out what their strengths are, and guess what? When you go to hire for that position, you have them take the assessment. It's very inexpensive, and if they don't have those strengths, guess what? You're not going to plug them in to be a pattern maker that's on the bench, or that's programming. Somebody might have a certain things that really plug into that situation. So I'm excited about that, but just as a tool, I mean, it's really important for you guys to have the community involvement, so that you get that buy-in from the community, and people may not even know that they exist, and they wouldn't know if Keith wasn't forward thinking, or the whole team at Hoosier. So kudos to you guys.
It's interesting. There's the foundry industry in itself. I don't know that a lot of people are familiar with it. So, and what they do know, they know it's dirty and it's hot, and nobody wants to work there. Well, um, just the education, just getting the community involved to see what it actually is and what kind of neat stuff you guys can do is pretty cool, because they come and watch, and they see iron being poured or whatever at our annual iron pour, and the light bulb kind of goes on, and they get a smile on their face, because this is
Yeah,
really cool. And they want to get, next year they want to get involved with the scratch molds or whatever. So it's it's
that is awesome,
education,
and that you guys are doing
which
iron is even
ultimately ends up
more
benefiting.
cool about it. Yeah, that's really awesome. So about the iron pour, who does
Yeah.
that? I mean, does Keith have a cupola, and you guys have your own thing, and you go set it up out there, and you guys have the expertise to do that, or does somebody come in and do that, or how do you partner with somebody?
So this will be our third year. The first year we partnered with a group out of Wisconsin, some artists up there that do an iron pour each year. And so they came down, they brought their cupola and set up, and we printed scratch tiles. People carved their design into it, and then we got everybody together and we poured them. The next year, Keith and his mentality, he went ahead
That
and
sounds
built a cupola, a monster thing that uh, was bigger than we probably needed last year, but we're trying to get it to the point where we can start doing these ourselves. The group from Wisconsin, they came down again. They're a great group of people, a lot of fun to work with, and they do some neat stuff. But so we've been working side by side. But we're trying to get set up. We have the equipment that we can do them ourselves if we want to.
that's cool.
It's community involvement. It's pretty cool. Last year we got involved with the local second grade, the local school, the entire second grade class, and took I don't know 120 of these little scratch tiles over to them, and they had a meeting, and they happened to be studying butterflies or something, so they all carved their butterfly design into this mold and then had them poured. And we tie that in with the art walk. So the next day downtown Decatur, they had a board set up where they displayed everybody's iron piece that design or whatever that they scratched out. So the kids came and picked them up and could show their parents or their friends or whatever, this is what I did, and then they got to take it home with them. Well, this year that was one class, and then another art class. This year we're doing 2 grades in that same, plus an art class in that same school. We picked up a second school where we're doing, I think, 4th graders, and then we picked up the Boys and Girls Club. So I think we went from like 125 scratch tiles for the school last year to we're up somewhere around 500 scratch tiles this year, and that doesn't include any of the community and coming in yet and doing
Are
their
those
design.
individual?
So, but getting
Go ahead.
what's
Are
that?
those individual molds that you guys?
As Yeah, yeah. So they're just they're octagons. They're roughly 8 inches, 8 by 8, and they're recessed down about 3/8 of an inch or so, maybe not quite, so that you have, when you pour into it, you have something to hold the iron. But they can carve their design into that block, whatever they want to do, and then we just pour into the back of it. So it's just an open pour or whatever you
Just an
want to
open
call it.
face pour, yeah.
Yeah.
Okay, cool.
So there's a couple things that are kind of have turned out to be recurring as we've been doing these podcasts that I'm hearing again here. One is people are surprised about how clean. Now, I realize that I think the place that Nate came from may not have been as clean, but the place he's got now is clean. And we talked to Tony at Art Castings. His place is, I mean, you could eat off the floors in his place. It's immaculate. And Todd, you're talking about the cleanliness of the place. The other thing that kind of keeps coming back around is this notion of, I want to call it family within the company, and which I just find remarkable because I haven't experienced that. And to hear you guys talk, just continually talking about people that are hanging around, people that have become just part of a family. I'm curious, are your employees like, what kind of longevity are you getting out of people? Are they there for 10, 15, 20 years, or they hanging around for 3 years and moving on? Or
It varies. We have people that I think we have one guy that's I just saw the notification that he's pushing 20 years. He has his 20-year anniversary coming up. The company's been around for what, 20, what did I say, 27 years, something like
okay.
that. So, 20 years or 20 years plus is pretty good. And our cleaning lady, she's an incredible person. I wouldn't want her job to save me. I mean, you walk through the plant and she's down on her hands and knees, scrubbing around one of the machines or whatever. So the cleanliness of the plant is, it's a I lost the word. I mean, everybody does their part, to keep things clean. But when it comes down to it, we have two ladies that that's what they do all day is sweep the floors and wipe down machines and wash windows. And the other day I walked through and one of them was, this should tell you something. I found it interesting. There was somebody sitting on the floor in the break room wiping down a trash can so the trash can didn't look bad. So, um, but so yeah, you walk through here, it's not a typical machine shop. The sand room, you have a little bit of sand on the floor, but that's all swept up and cleaned up every day.
Yeah.
It's a very, very clean place.
Well, I just recently
You,
heard a story about the owner of a foundry trying to put together a floor sweeper so he could keep the floor clean, but I think he struggled a little bit on getting the brushes attached. But
That Chinesium thing, I could have swore they only sent me one broom. They were nested together. When I took it apart, I looked at it and they come apart. And I was like, oh God, I'm such an idiot. Okay, I take it back. Those Chinese guys, they did exactly what they needed to do. I'm an idiot. So I readily admit it that it was a mistake on my part. It wasn't them. So yeah,
I thought it was
I take
hilarious.
it back.
See, now what I would have done is I would have posted it out to YouTube and Instagram and everything else saying what dummies these guys are. And then I would have had to retracted it publicly. So at least you didn't go that far.
I will say it's on my Snapchat.
well, that's the
But
nice.
I did retract it by saying, "Hey, I was incorrect and I was an idiot." It was all there, perfectly fine.
Yeah.
Well, so that's good to hear because I think most of the time the philosophy with the internet is you can say anything and everything that you want, whether it's right or wrong, and you never have to retract anything that you say. So
Yeah.
it's kind of frustrating
Well, those are
sometimes.
the people that
Yeah.
have an
Yeah.
ego and they're not humble and they don't admit when they're wrong. There's a lot of people out there that like that. I mean, I know people in the foundry industry. They just won't admit when they're wrong. They just drop it and go on. So anyway, but I would like to correct something. So D Foundries that I managed for 12 years, it was built in 1934. It looks like it's got a lot of patina on the outside. You can look it up on Google Maps, that sort of stuff. But the inside is actually pretty well lit and pretty darn clean. It was one of those things that Robert Wolf, the owner of the facility,
Okay.
he's definitely a cleanliness guy. So it's one of the things, is one of the pet peeves. A foundry is inherently dirty anyway, and his saying is, "Man, we don't have to add to it. Let's keep it clean." And the guys really do a good job of that. So not fair is fair and right is right. So definitely kudos to him for doing that.
Well,
Good.
I had the opportunity to go through D with you a couple years ago, and yeah, I didn't think it was bad. I think the thing that I like the most, or that I find the most interesting when you have a chance to go through founders like this, the buildings are old. The buildings have a ton of character, just in the design and the way they're laid out, and it fascinates me to be able to walk through these old buildings and see what's being done. So.
Yeah, and most of the people, actually,
Yeah.
most of the people in that neighborhood, they have no idea what's going on behind those walls at all. They have no idea. There's no open house. There's nothing like that. But it would be eye-opening to them. But you also got to be really careful whenever you're pouring certain alloys. Certain people come through, and you're like, "Oh Lord." I mean, it is a thing. Just like we talked about with Chris Greenfield from the Federal Metal Company. I mean, the first thing he said was, if somebody is pouring ingot at their house, trying to refine it so that they can sell the ingot and get more money out of it. He's like, well, first off, we're going to verify that it's you haven't stolen it from one of our customers, and that it's actually something that you poured. So that him leading off with that's a big deal. People do steal copper-based alloys or even stainless steels and things of that nature. So it's so easy for theft of metal, especially the ones that are very expensive, especially since they pay cash. But fortunately, they've made some real headway in tracking people down and fingerprinting people and having IDs that they've got their pictures and that sort of thing. So if they figure out who did it, they're ratcheting down on those guys, which is really good for the industry and builders and electrical companies and contractors and things of that nature.
So let's switch gears a little bit here and talk. Let's talk about Hoosier and let's talk about what you do, Todd, and what you guys do for products. Because you have a couple of different product lines, right? You've got sort of your traditional wood, I assume they're wood or maybe they're 3D printed patterns. But then you also have, you have the additive manufacturing part where you're doing 3D sand printing. And I'm curious at this point, are you starting to see one more prevalent than the other, or are they kind of the same, or have they stayed the same, or what kind of things are we seeing in that space?
Sure. Let me back up for just a second. Yeah,
Okay.
we have the tooling side, the conventional tooling side. We will machine just about anything but wood.
Okay.
We'll do because and we still on occasion have people reach out for wood patterns, and we have to tell them that sorry, no, we can't do that. We don't have the ability to do that. Or we're not set up to do that anymore. That's definitely an art.
So what are you
So
making your patterns out of then?
So we'll do, high volume production stuff, maybe out of iron or stainless steel or
Oh,
some
okay.
sort of tool steel. If it's prototype work or a lower volume, then we'll do the Ren boards. We'll also do the Foundry planks. Um, you know, red, green, orange. It's the color of the day, whatever somebody prefers. But so yeah, and we've done some foam patterns as well, just lower density foam patterns for like the fiberglass industry.
Mm.
But all in all, we'll do just about everything but
Wood.
traditional wood.
Okay.
So
you're
yeah,
not technically
so we
wood
don't get
butchers
a bunch
then.
of emails all of a sudden.
You guys aren't wood butchers then, is what you're saying.
We're not
Wood
what?
butchers. You're not wood butchers in the pattern stuff.
No, correct. Yeah, no. We do have a couple of our rigging guys or our old time pattern makers. That's how they started out with the traditional wood pattern. And I think they brought a couple of samples in at one point and had them in the benching rigging area, primarily to show the apprentices. This is how it used to be done. Because
Back when men were men, and
yeah, exactly. Now it's all done on the computer and it's easy, right? But no. So yeah, some of that stuff. I mean, it's really impressive what was done. The patterns. You find the right patterns, and it really is artwork. I
yeah.
think there's some people that will buy those or find those and put them on display in their house. But anyway, it's really cool. So your question about the mix, what I typically tell people, it runs anywhere from 50-50, the tooling side to the printed sand to it may fluctuate as much as 40-60. But all in all, it stays pretty close.
Yeah,
And
sounds like it. Okay.
we've seen times where the 3D printing sand printing side is busy and buried, and the tooling side is a little bit slower, or the tooling side is buried and the 3D printing side is just a little bit slower. But all in all, they kind of balance each other out. So um, it's been good. When we were strictly tooling, we had a handful of tooling customers that we would build, quote, and build product for. And when we got into 3D sand printing, that the customer list just went crazy. Hundreds of customers or whatever now. So a lot of companies talk about being diversified. Well, we're diversified. We're not strictly one or two customers that are the majority of the business. So um, when markets swing, it's not as painful.
Yeah. So one of the things that I mean, I just recently learned this. I don't know how many of our listeners already know this. I assume probably far more than I imagined. But can you tell us a little bit about what 3D sand printing is all about? I mean, I was really fascinated to see it when I first saw videos of it and saw how it worked. I was just like, wow, this is this is pretty darn cool. Another thing I remember seeing was the idea of using the loose sand, to kind of protect the mold as you ship it. But maybe just talk a little bit about what that looks like.
Yeah, sure. One of the things, the fun thing or the interesting thing about 3D sand printing, a lot of people have heard of plastic printers, and they talk about a build envelope that's maybe 10 by 10 by 10 or 12 by 12 by
Right.
12. The build envelope is pretty small.
Yep.
And then when you start telling them about 3D sand printers and you tell them that the build box is roughly the size of a refrigerator, people kind of raise their eyebrow like, wow, that's huge. So That's kind of fun in itself. There's just the volume that we have to work with, so the way the printer works for the people that don't know, the machine, the sand is introduced into the machine. There's a mix pot, and there's an acid activator that's mixed with that sand. That's kind of the first part of a two-part chemical reaction or whatever. That sand is then transferred to, we call it a recoater, and that recoater is set up to meter out an 11 thousandths layer of sand across the entire build box. So 0.28 millimeters, 11 thousandths. And then what happens, there's a print head, just like your inkjet printer. There's a print head that comes back, and it makes 4 passes on the job box to cover the entire job box. And on each pass, it's actually printing the cross-sectional image. So the way it works, the software will take whatever's in that build box and divide it up into 11 thousandths layers, and takes a snapshot of that layer, that cross section, and then that's what it's printing each time it lays a layer of sand. So the recoater will lay the sand down, the print head will come back and print the image, and then the build box, the floor of the build box will actually drop down 11 thousandths so that the recoater can come back in and lay another 11 thousandths layer of sand. So it just keeps repeating. You're actually building down into the build box. Um, so when
And
it's all said and done,
you're
what's
putting a
that?
layer of sand across the entire build box when
Yes.
you do it, right?
Yes.
And then
Yeah.
you're printing this. Is it a resin you said that gets printed?
Yeah. So it's a Furan binder system, which I think most Foundry people are familiar with Furan.
Uh-huh.
So yeah, it's a Furan binder system. And wherever the Furan comes into contact with the acid activator, that's where you get your chemical reaction, and that's what gets hard. So, the nice thing about laying unbound sand across the entire build box, now all of a sudden you don't have to necessarily worry about undercuts or overhangs. On a 3D plastic printer, if you have an undercut or an overhang, you have to design in or account for support material.
Right.
Well, all in all, the loose sand that kind of works as a little bit as the support material. Um, so when the job box is done, the job box is shuttled out, and all you see is just a full job box of sand, a flat layer. So at that point, they'll start using vacuum, or we have troughs that we can move all that unbound sand out of the job box to actually dig down to the molds and the cores. So they advertise it as being archaeologists. You're out there digging for buried treasure. Um, so
Now, out of curiosity, because
Okay.
Perry's familiar with it with a 3D filament printer. A lot of people are. They're fairly
Filament. Yeah.
inexpensive, that sort of thing. But one of the things that you run into with a filament printer, and I don't know anything about the 3D sand printers, but you've got that build plate, right? And I'm assuming it's some sort of a really flat surface. Maybe it's steel or aluminum plate that's in there that's getting moved up and down. Does it get wonky and out of whack? With you guys have to like lay some sand down, so you're starting with something that's flat, and then or you have to, because a lot of times with filament printers you have to readjust your Z height so that you're actually getting a good first layer down before you start printing. Is that similar in 3D printed sand?
well, yeah, so the printer, before it actually starts printing the first thing, it's going to put, I don't know, 12 or 13 layers down, so that it's starting out with a nice flat consistent layer bed of sand to work with.
Oh, okay.
So
Okay, sweet.
And then I mean, you laid this stand down, and how reusable is the loose sand? Is that something that can either be reused as it is? Can it be cleaned and reused? What's kind of, I guess, what kind of green technology do you have there?
So when we first started printing, the printer manufacturer X1 specified that we could reuse about 30% of that once used, we'll call it once used sand. So, if the sand was laid down in the print bed, it has activator on it. We could vacuum that back out, put it in a silo, and reuse about 30% of it. Um, if you use more than that, then you struggle with getting the proper ratios of activator binder. You may struggle with strengths and stuff like that. So beyond everything else, ended up going into a pile and then ultimately getting shipped to the landfill. So the first several years we sent a lot of sand to the landfill. And of course, you pay to get rid of it. And so a few years ago, this has been a process that's been going on for, I don't know if it's 3 years or more. We installed a thermal reclaim system. So we take all of our used sand and run it back to a thermal reclaim system to burn off all the binder and activator to get it back to its virgin state. So then we can reuse 100% of that again. So there's very little sand. If there's some sand that makes it onto the floor or whatever, we'll sweep that up and put it in a dumpster and that gets hauled away. But everything else, as long as it's clean sand, goes through the reclaim system so that we can continue to reuse it. So we've greatly reduced the amount of sand that we're taking to the landfill and having to dispose of.
That's got to
So
pay all kinds of dividends from
yes,
initial cost to disposal cost and all that. So
so it's been a learning curve. I'm glad we're where we're at now. It's been a we've done enough work and redesign. It's a reliable system. It seems to run well. It was a good choice because we're going through more sand now than we ever have. So I can't imagine how much sand we'd be taking to the landfill if we weren't thermally reclaiming it. So
how much are you reclaiming? I mean, just like, is it measured in tons, I assume? Or, I mean, how much sand are you guys actually reclaiming in a week, a month, a year, or whatever,
oh, uh,
a day?
I know our maintenance guys are on top of that. They would probably have a number off the top of their head, but um, I'm not sure what that number is. I know it's enough that we're supporting with the way we're set up. We have 7 machines here. And we may not run all 7 of them every day, but we're pushing sand to 5 of them. So depending on what we're actually printing that week or on that machine, may decide whether we're running our reclaimed sand or we're running a carboceramic material, or we have a uh, um, a virgin silica sand that we may run for some customers. So we're running 3 machines, which is, I don't know, is that roughly 3,000 pounds of sand a day on virgin sand or on reclaimed sand. So, um, and
Wow.
we seem to be keeping up. So what is that? I don't know if we're at 10 or 12,000 pounds a day right now on
Yeah.
reclaimed sand, somewhere in there.
Wow.
Is
Wow.
that the only thing you're running through? Is just regular old silica sand? I mean, a lot of times, I mean, you have sent us some carbo cores in the past for some special jobs that needed the strength and things of that nature. So, which carbo is for the listeners is ceramic sand, which is a man-made manufactured product, and then also additives that you got, whether it be black iron oxide and things of that nature for veining defects and things of that nature. Is that are all your machines capable of that, or you just have certain machines, or how's that work?
So we're running, whether it's silica sand or silica sand with bio, we're running through one thermal reclaim system. We have magnetic separators, so we can pull out all the black iron oxide and get it back to the kind of the virgin state. We are just finishing up installing a second trommel system, a second reclaim system, where we're going to start to reclaim carboceramic. And that's been a little bit more of a challenge. Carbo has a tendency to hold heat a little bit more. So, running it through the thermal reclaim system and then running it through the cooler classifier, it's been a little bit more of a challenge. But carboceramic, it's a great product. It's just a little, it's a little on the expensive side. So, anything that we can do to be able to reclaim it and reuse it, not have to send it to the landfill is a win-win. So
Yeah.
as far as we know, as far as I know right now, I don't think there's anybody else out there reclaiming carboceramic.
Right.
So it's been a little bit of it's been a little bit of a learning curve, but we're
So
getting
when
there.
it comes to that, I mean, is there certain processes you guys have to use to be able to do that? Because with the Furan sand, I mean, is because you're basically, so for the listeners, because they can't see what the process is, the sand goes through there. You guys are vacuuming it up. You've got it in bins. The bins go to the thermal reclamation, and it's fed in there, metered in there somehow, so many pounds per minute or pounds per hour or tons per hour. And then is that a continuous? Do you run that 24 hours a day? And then it transports again pneumatically with air to or bucket elevators to another silo, and then you guys can take that out and put it into your bins that you actually feed the 3D printers with, or what is the process involved with that?
Yeah, so on the silica side, if we have the reclaimed sand, or if we have the sand to reclaim, it can run 24/7. But we have silos set up where it'll feed the sand into the reclaimer. It burns it, puts it into a holding silo, and then we actually have a sand transport system that can push sand to 5 of the 7 printers. So, it's set up that, if the printer calls for sand, then, it can automatically push sand and keep the
That's
silos
way
full.
better than what I was thinking.
So we have enough.
I know. I'm
So
picturing a
Yeah,
guy
yeah,
with
yeah,
a
yeah.
bucket of sand walking by every printer and dumping it in.
um, we have enough sand at the machines. The machines could run 2 days. We have plenty of sand at the machine. So it makes it kind of nice. So basically, all the transporter's doing right now is just kind of keeping things topped off. And we can turn certain printers on and off. If we don't need it at 2 of the printers, then we shut those off, so it's pushing to the ones that we need it at. But it's been that too has been a nice addition, along with the reclaim
What did you
system.
guys do prior to the carbo or the ceramic sand reclamation system? You just threw the carbo away, or did you bag it up and send it to a foundry? Like you could send it to KN for that matter. We could run it through our system. We have a thermal reclamation that we could utilize that. But I mean, what did you guys do prior to that?
So I don't know if the owner may not want me putting this
Don't
out
say
there,
it
but
then. Don't
um,
say it.
we,
You're being
well,
Yeah.
facetious, I
no,
guess.
I'm kidding because what so we we were started out with reclaiming silica sand, and there was always talk, I think, from the start to um, looking into a reclaiming carbo as well. So all of our used carbo was put in super sacks and then put in storage.
That's smart.
So we have a barn set up with a whole bunch of carbo in it that we're just now starting to pull that back out and
That's
run it through the
awesome.
reclaim system. So yeah, instead of sending it to the landfill, we've been holding on to it so that we can get it back to a point where we can
That's
reclaim
smart.
it. So
Very, very smart. Okay. Well done, Keith.
Keith is
So,
a uh, Keith is a forward thinker. I say um, we think he has crazy ideas sometimes, but yeah, he's
Yeah.
he's he's on
Well, I
top
mean,
of it. So
listening to the story from the website, I mean, they started from scratch. So to get to where he's at today, that's pretty impressive. I don't care what anybody says. That's kudos to him and kudos for building a good team and having a good team that
yeah,
can actually take take the ball and run with it. Again, Keith doesn't have Hoosier Pattern without you guys, and he knows it for sure, without a doubt. So as far as after the molds go to the foundry, and so when we receive mold packages in from Hoosier, a lot of times, just so the listener has an idea, so we assemble these things. We purchase all of our mold and core packages uncleaned. Now, I don't know what percentage of mold packages that Hoosier produces and ships out that are cleaned, because I could see some foundries not wanting to have to take the time and to spend the labor on cleaning the sand out of the molds. They've got a lot of different tools and processes and lighting and downdraft tables, because it is free silica and you don't want your employees breathing silica because of silicosis hazard that goes along with that. But we find that our prices are cheaper. We're pretty efficient at cleaning them as well. The other thing about it is, whenever we clean our mold packages and our core packages, we get to put our eyeballs on it. We get to inspect every square inch of that rascal. And so therefore, if there's something wrong with it, we're going to know it. Whereas if we brought it in, took it all apart, blew it all out, put filters in it, assembled it, and poured it, you may not have the same bit of knowledge of, because you know it inside out at that point. So that's kind of my thought process of why we buy stuff uncleaned. The other part of that reason is it's cheaper. B, it ships better, but you do have a heavier mold package, right? Because you've got extra sand in there. So your weight for shipping is going to be a little more expensive. But if you've ever done the experiment in school and middle school where they want to take your science class wants to take an egg and put it in a box, and you got to make sure you got to throw it off the building and you got to make sure it doesn't break. Well, one of the things you could do is embed your sand in something. Well, our cores a lot of times are fairly fragile, especially it depends on what the geometry is. And so if we have it embedded in sand inside the mold or inside of a 3D printed mold box, well, it typically, I've not had one show up broke that wasn't broke by an associate or a teammate that broke it whenever it arrived, opened it up, and it's like, oh crap, this is broke. Well, yeah, it's broke because you tried to pull it out of the sand instead of removing the sand from it and pull it out. It was gripping it. So that's probably the only time we've really had that issue. Hate to even admit it, but that is, I've called Todd and I was like, hey man, and the pictures that we take of it, it's like, okay, this doesn't make any sense. Todd's like, no, that's almost impossible. And so we've had those conversations, which I don't like having those conversations, because then you're talking to your teammates about it, and they're like, yeah, well, okay, well, just admit that we broke it and let's go on. Typically we can make it right one way or another, but that's the reason why that we buy things uncleaned. Do you have a lot of people that purchase it cleaned versus uncleaned? I mean, is it 70-30, 30% buy it uncleaned and the 70% buy it cleaned?
That's a hard ratio. It probably fluctuates. I don't want to say it's 50-50. It kind of fluctuates. There's a lot of production cores that we're printing now, that we clean and ship weekly.
Okay.
A lot of I'd say probably I would probably say more customers prefer to have their molds clean than unclean. Especially if it's a number of them or whatever. But um, you know, you had mentioned that there's definitely the right case. If something's pretty fragile and we don't think we can get it to you, then we're going to ship it inside of the mold, like we have in the past to D, or the KN. But I'd say if it's something that we can clean, we definitely do it. Um, it depends. I'd say that we've, as far as customers look at it, yeah, we can typically do it a little bit quicker if it's shipped unclean, and we can do it for a little bit less cost. But especially on the production side of things, if somebody's ordering 50 or 100 cores, they basically want them ready to go when they get to the foundry, instead of having to deal with pulling them out and cleaning them and getting them ready to
And
use.
that
So
makes sense to me,
um,
because if they were going to be
that's
production
it.
cores and I needed 1,000 cores from Hoosier or whatever service bureau that we're using, well, if I'm going to bring those in, guess what? I'm going to use your labor. Yeah, I got to pay a little bit for it, but I don't have to worry about somebody showing up to work to do that particular job. I can bring them in kind of like the Toyota way, right? You want it to be as efficient as possible, so when that comes in, it's ready to use. So that is completely normal and makes sense. We have customers that want turnkey parts. I mean, I don't necessarily always never really looked at being in the machining business, but some people don't want to have to deal with the shipping to go to the machine shop, and then if there's an issue, that they have to deal with that, and they want the foundry a lot of times to machine those particular parts so that they get a good part every time it shows up. There's no quality problems, because what inevitably what happens is the variables of producing castings is not we've talked about this before. It's not super easy. So there's things that we can control, so we have to really control the things that we can, and the variables that we can't control, like the weather and things of that nature, that people just throw it up as voodoo and pixie dust. Which is, there's a reason why certain things happen. We just have to try to mitigate those as best we possibly can with our processes in the foundry. But yeah, that's interesting. But I could see why people would do that, because it's more efficient to bring it in, assemble it, pour it. And time is the one thing that we don't have. So in the business that we target and we really do well in, it's all about lead time. We don't have time to wait a week and a half, 2 weeks to get a mold package. We got days, and even we have transit time that we have to put on that too. So anytime you're dealing with that you gotta make it work and be as efficient as you possibly can for all of that sort of thing. So it's one of those things you got to do that and make that work for the job itself.
It's Yes, and it's interesting. It is kind of customer specific. So, the particular customer that we're shipping molds to you unclean, if we print something for them and ship it to somebody else, uh, because it's a different alloy or whatever, then it's shipped uncleaned as well. I mean, I think they go with the lead time
Sure.
more than anything else. They want it printed and shipped as
Right.
quick as
Exactly.
possible.
Yep.
So,
That makes a lot of sense.
So I have a question about this. I have a question about this cleaning stuff. Because I don't clean anything. Ask my wife, right? Um, but I assume. Well, so first of all, I guess based on what you said, Todd, are these things typically one part molds, or because you're printing this refrigerator sized box potentially of stuff, or are they multi parts so you can get them apart and you can get in there and clean easily? Or are you having to follow the runners and the gates and stuff to get your cleaning tools up inside the mold to clean them out?
so with our particular process, we're gonna we're gonna ship a mold that's probably split into a cope and a drag, or a cope cheek and a drag, separate cores. Our particular process, we could not print a one-piece mold and be able to get all the sand out of it.
Okay.
The sand is slightly sticky, and so we need to be able to get in there and actually see it to remove it. Now, there's some blind areas, depending on what the blind area is. We can get in there with tools, wires, whatever, to be able to kind of loosen up the sand enough that um, once we get the majority of it out, we can hit it with air and finish cleaning it. But in general, we need to be able to kind of see all the areas to make sure that the loose sand is removed. Um, so.
So
Okay.
so all of the printers, the 7 printers that you have at Hoosier, are those all Furan? There's no CHP printers there, or anything else like that to meet a certain demand. Which I know that it obviously, when you deal with phenolic urethane and versus furan, you're going to have issues. Now you got a third reclamation system, right? So it really doesn't, unless you just had a lot of demand for it.
Yeah.
He's going to go, no, you're an idiot. We're not doing that. We're going to stick with what we got. The carbo with the ceramic sand and the silica sand for furan is what we've got. So
Yeah, we're all 7 of our machines are the Furan based machines. We do not have the ability to print phenolic. Um,
Nate, how do you guys deal with that on your side? You get this mold in. It's just I can't say the name.
Furan,
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 No,
Furan.
Furan. You get this mold that's based on that. It's hardened with that. What do you do with it once you've poured it?
So
Is that something you just dump in the
oh
landfill, or
no,
you clean
no,
it up, or
we're much more sophisticated than that.
sophisticated?
So what we do is we have a Palmer shakeout deck. It's like a 5 foot by 5 foot shakeout deck. It's mechanical reclamation. So basically, what it does is it takes those lumps of the sand and it basically sands them down into grain fineness, right, or really really close to it. Then it transports it from there. We run it through a cooler classifier because the sand's going to be hot once it's next to the metal, right? So we run it through a cooler classifier, which is a water cooled cooler classifier that comes from our cooling tower, which is recycled water over and over again. And then from there, we transport it to a holding silo because we brought the temperature down at that point. So it's not going to draw. The reason for that, you don't want to be doing it. You're going to burn your gaskets and stuff up in your pneumatic conveying equipment, but it'll actually draw moisture and stuff if it's elevated temperature, not closer to ambient anyway. And then from there, we have thermal reclamation as well, built by Palmer Manufacturing. I don't even know what serial number it is, but it was one of the early ones that Jack Palmer had designed, and it's an electric rotary thermal reclamation system, and we run it through there. It goes through a bucket elevator, cools it back down, and then runs it through a bucket elevator and then to a sand transporter, and we put it in our holding silo. We transport that to our we have a pneumatic conveying system that actually it transports it, and we fill boxes up, steel boxes up with it, which would be very similar to what Hoosier does, because when KN bought the assets of Pump Works Castings in Lufkin, they in 2022 they had two X1 printers, Furan printers, just like what Hoosier has. So we have everything in place to do all of that sort of thing. So what Todd is saying, I mean, we do that at KN. So we're able to recycle all that sand. We don't purchase a lot of new sand at KN Manufacturing because we're constantly bringing mold packages in. I mean, the vast majority of the stuff that we do are quick turnaround jobs. Customer doesn't want to call Hoosier and say, I need traditional pattern tooling, I need this stuff done. Speed is the thing that moves our business and moves the needles for our customers. So everything is super efficient. Quick ship is like standard procedure for us. A sense of urgency, you're not going to get 8, 10, oh no, it's going to take us 16 weeks. No, that doesn't exist with us. So the reason for that is, and we've got the ability to add that sand to our system. So we send very little out. You might get rid of 5% of your sand that goes on the floor, or it's messed up, or a forklift might have had a little bit of a hydraulic leak and it got some sand on it. Well, you're not going to put that back in the reclamation system. You're going to pitch that. So you're going to have stuff like that all the time. So that stuff we do send to the landfill. But if we get a 3D printed mold package in that is a phenolic urethane, a CHP, we typically pitch it. We throw it away because it will contaminate our Furan sand system. So there's an ester in there that creates a problem. So we don't want to do that. And but there are workarounds to that, and sometimes it's just a matter of you throwing it away. But there are other foundries that Furan system that if they don't have any reclamation or anything like that, it's a one-shot deal. They use it, they throw it in a big old pile, they have a front-end loader come in, and they haul it to the landfill. But with that being said, when I say they're sending it to a landfill, it depends on the area. Like in Houston, for example, we would have a recycler come in. They would take that sand. So you're just not just creating more stuff for the landfill. That's a recycler that you would actually have to pay the recycler to take this, because a lot of times that stuff was in lumps. There was no mechanical reclamation. There was no thermal reclamation. There's nothing sophisticated about it other than knocking the casting out of the mold, and you shove the lumps over in a big old pile till you got enough to have the truck dump truck come in and haul it off. But the recycler takes it, and then they turn it back into grain finest, kind of like our mechanical that we've got at KN. And into grain finest, they actually put that into asphalt production, that sort of thing. So it's a byproduct. It gets utilized in that way. So it does get recycled in a green manner, not just going to the landfill and saying, "Hey, no factor. We're just contributing to the growth of the landfill." That's not the case. Most of the stuff gets reused in a beneficial way for the environment and to be good stewards of the environment. And that's what we did at D. We had a contract with the recycler that is regulated by the TCEQ for environmental purposes, and it was recycled in a positive, good manner for the environment.
Oh, I mean, that's another recurring theme, as I'm hearing over and over again about these foundries. Very green industry, right? I mean, you guys are recycling a lot of stuff, not creating a lot of waste. So that's super. I think it's something that a guy like me I just wouldn't have thought of that right off the bat. But I guess after I had a mountain of sand sitting on my on my foundry floor, I might start thinking about in terms of,
well, and for the most part, most foundries,
stuff.
I would say that it would be interesting to know of the foundries that are still left in the U.S., how many of them actually either do mechanical reclamation, which is a form of recycling internally, or mechanical and thermal reclamation. Because thermal reclamation is kind of the gold standard. I mean, it's the way that you should recycle your sand, because what happens is you coat that sand with that resin or that glue, and you need to burn it off, because what happens is you coat that sand, and you let's say you only do mechanical reclamation. What happens is you coat that sand over and over again. You put more glue on it. You put more glue on it. Put more glue on it. Well, that is a hydrocarbon, and it's fuel. So whenever you pour molten metal on it, if it gets too much fuel there, you're going to create mold and core gas, which is not good. The mold and core gas, if you don't deal with that, and you have to check for that, and there are ways for us to do that in the lab, taking a sample of it, checking the LOI, which stands for loss on ignition. How much fuel is on that grain of sand, and how do we control that? We need to keep it below a certain threshold for the LOI, so that we don't give it more fuel or hydrocarbons to burn to create core and mold gas. That's just part of the, again, Foundry 101 and Foundry fundamentals. If you're not paying attention to your LOI, and you're going to start having defects, and they could be subsurface defects that you don't see until that casting gets machined. The first cut comes off, there's like, oh crap, we got quote unquote porosity. It's the general term for what it is, but typically it's because it's mold or core gas, most generally.
Yeah.
I'm glad you mentioned even your LOI testing, because that kind of lends itself to, we don't pour anything here, of course. We're just a pattern shop or a 3D
Well,
printer.
once a year you pour iron, right?
Yeah, once a year we pour iron. That's right. We're experts now. No,
Experts.
but one of the things that we want to make sure when we print a mold and ship it to somebody like Nate, we want to make sure it gets there and they go to pour the casting and they get a good casting. So, we're checking the LOI, we're checking the binder content on all of the printed sand that we produce as well. So we're mindful of the higher binder levels. I think we're typically, I want to say around 1.2%, something like that. Because we want to make sure that when it gets to the foundry that they can get good castings. Printed sand isn't necessarily cheap. You compare it to the traditional mold making process. It's not something that you want to have to buy extra molds. It's kind of, you buy a mold, the goal is to get a good casting. So
Yeah.
we're
Yeah.
checking LOI, but some of the other stuff that we're doing. Every job box that we run, we put a series of test bars in. So we have test bars aligned in the X, Y, and Z direction and spread out through the box. So we can't physically measure every part or every mold, every core that we print. So every job box has these test bars that when it's done printing, we pull a handful of them and do an initial test. And we're looking at dimensionals. We measure them and to make sure that the test bars are in spec. We're checking break strengths to make sure that the cores are as strong as they're supposed to be. We're doing an initial LOI to make sure our binder content is where it's supposed to be, and we're checking permeability. We want to make sure that you can get the you call it natural venting or whatever you want to call it, but from that initial test, we can say, okay, yes, this job box is good, or no, this job box isn't good, and we need to reprint it. So we want to make sure that what we send out, we know what it is, and we know that it's in spec, and that when it gets to the foundry, that it's right. Because it doesn't do us any good to ship out product that's scrap, and it doesn't do the foundry any good.
Doesn't do that many good either.
So,
Yeah. So is your testing, is any part of that destructive, or is it all sort of non-destructive testing?
It would all be destructive testing, but since we're just talking test bars and we're not testing physical cores, then it doesn't matter anyway. So we break the test bars, throw them back in the dumpster, and then eventually they go back through the thermal reclaim system just like everything else, and we can reuse the sand.
And
But that way we don't.
I was going to say, you print the test bars as part of the mold.
They are separate. They are separate from the mold. So it's 15 bars that are roughly 172 millimeters long. So we orient those or position those in the job box, spread them out across the X and the Y, the length and the width of the job box, and then also we try to get them at different levels. So when we do our testing, we can get a general sense of the entire job box.
Okay. Okay.
So yeah, we can't physically, as many molds and cores and stuff as we print, we can't physically measure every single core that we send out. So that's why we use the test bars the way that we do. Um, we keep a log as well, just to make sure that, if Nate has a problem with something down the road, um, we can look at back up, see when it was printed, what machine it was printed on, and go back in and look at the test results to say, yeah, this is where we're at, or everything was good. Which, if it shipped, it it's going to be good, but we still keep that data so that we can go back and troubleshoot if something happens down the road. So.
Right,
So,
right.
just out of curiosity, do you actually name the 3D printers, the 7 3D printers that are out there, or do they have names? Or, and the reason I say that is because I named my 3D printers when we had them, Tom and Jerry. I never named the stacker. I just called it the stacker. But the other ones were Tom and Jerry. I was going to call them Cheech and Chong, but we had an incident with some of our employees, our teammates that were out smoking pot at lunch. So I didn't want them to think, anybody on the staff at D, to think that it was okay for us to call it Cheech and Chong, and then we're embracing the pot smoking at lunch type thing. So do you guys name them at all? I mean, Tom and Jerry is pretty tame.
Um, Actually, no, we don't have names for them. We call them by their serial number. That's how they're identified. The only one that potentially had a name was a one of the machines that they had moved out of Mexico, and we may have given it a Mexican name because I don't remember if
May have.
may have, and unfortunately, I don't remember what that name was right now. It just seems to me that when they fired up the machine, uh, somebody's name was, I don't know if it was the login or somebody's name was on it. So we naturally, I think, started calling that printer by that name. So, um, but we do joke, hey, equipment, it's temperamental. When you're around the equipment, you have to talk nicely to it, because if you
Yep,
don't,
yep.
you hurt its feelings, and then all of a sudden
Well,
it
and
wants to print
that's the
scrap
crazy.
for you.
Yeah,
So
that's the crazy thing,
they
because
may not
every
be.
piece of equipment, I don't care what it is, and it could be a dumb piece of equipment that just has an on-off switch or things of that nature. It's not as intelligent as a 3D printer or things of that nature, but they're finicky. They have personalities, whether we like to admit it or not. Computer systems, Perry, you could probably relate to some servers or something. They might be a little finicky, and they got this personality that every so often you got this thing happens, and you got to go fix the stupid thing. It's like, oh, there goes Tom again. Oh, he broke filament again, or the extruder isn't getting as hot as it should be, or whatever. I would think that all of those machines would have a little bit of a personality, where you call it Roseanne Barr, or you call it whatever you want to call it. Maybe it's somebody off The View or something. I have no idea, but they all have personalities.
Yep.
Well, we had issues to take that a little further. You don't talk bad about any specific machine, because
Yeah.
if it hears you,
Yeah.
it will tell the other machines, and they all go on strike. So it's you never want to say anything bad about any specific machine around so that other machines might hear about.
Yep.
Yeah. But yeah, you're right. They
Yep.
do all have personalities. So I wanted to ask another question about back to your printing, your 3D printing. Because, being an expert filament printer, I printed at least 6 or 7 parts now. I have my 3D printer specifically really to make patterns. I mean, that's really what I do with it, is I make patterns with it. And it requires a bunch of work to really, you can print it, but you can't really use it as a pattern because of all the layers. Every one of those layers wants to grab sand, and you've got to do something to finish that surface, to smooth it out, to clean it up, to make sure that there's nothing going to be grabbing. When you guys are printing sand, it sounds like you're printing about twice the layer thickness, because I was doing like 0.15 millimeter thicknesses. That's how my layers on my filament is. And you're at about 0.38, I think you said 0.38 millimeters, something like that.
0.28.
Okay, so we're about twice, almost twice. What's the issue is there an issue with the layers? I mean, I assume you're going to see layers on the surface. Do you do anything with them? Is that just customer part dependent? Do you need anything to clean them up if they need it?
So Yeah, no, unfortunately, no, we don't do anything to clean up the layer lines, other than we'll take a look at a part and try to best determine what orientation we need to print it in to kind of minimize the layers on critical areas. So, there's some aerospace, we're doing some aerospace parts, and, there's some internal cores that they want to make sure that we print standing up to minimize the actual layer lines.
Oh,
It's part, of course, it's part or geometry dependent. So, if you have a part that has some surfaces, horizontal surfaces that aren't quite flat, 5 degree angle on them or something or other, and we're printing them, trying to print them flat, you're going to see layer lines on
you're
them,
going to
and
see
there's
layers. Yeah.
nothing
I
we can
hadn't
do
thought
about it.
about that. I hadn't thought about the idea that you can print. I assume you can print in any orientation then, whereas like
Yep.
my filament printer, you're not only are you thinking about undercuts and draft and support systems and all that, but you're having to deal with the fact that I need to find the best orientation to be able to print this dumb thing on to minimize all those things. You guys have that advantage. You can print it any way you want just because you're laying down these layers in sand, right? I mean, you've already got the built-in support and everything.
Yep. Yeah, that is correct. And we do have to be careful. We can print in any orientation. One of the things that we do have to be careful of is when it comes to getting it back out of the job box again.
Mm.
If it's in a job box and you clean the top of it off, and like Nate had mentioned earlier, you just grab it and start to yank it out. Well, there's still a lot of pressure from all the sand around it, and you could break it. So, you have to clear some of the sand away to be able to get the core out. Well, you want to make sure that you don't clear so much sand away that the core falls over and falls on the floor and breaks. So, um, and there's stuff that we can do. We can print support blocks in there, disposable blocks or whatever, just to aid with getting it out of the job box.
Uh,
But for the most part, yeah, we can print in any orientation.
so it just dawned on me that's something else I don't understand. A myriad of things I don't understand. You're talking about this job box. I'm used to looking at molds that have, the mold is inside essentially a cube or a rectangular cube of sand, right? When you print a mold, would it be more akin to something that's done with investment casting where you printing a shell around the mold, or are you printing a box, a full cope and drag of sand? What does it look like when it comes out of this thing?
It's typically it's a solid block, so it wouldn't be it wouldn't be. I've heard of shell cores where they're hollow on the inside. But no, when we print a mold, it's a solid block of material.
So you're laying down furan all the way out to the edges of the job box then.
Uh, where the mold, we're laying down furan where the mold itself is
Well,
at.
okay, yes, right,
Yeah.
where the size of the mold would, or
Yes.
the cope and drag would be.
Yeah. Yeah, that is correct.
Okay.
So one of the things we found interesting, going back to the shell cores, uh, if there's a core that somebody might have a little bit of concern of getting out of a casting, we could shell the inside of that, give it a 1/2 inch or a 3/4 inch thick shell, and then leave all the loose sand on the inside of that core so that, when it's time to break out, you're only basically breaking out through, a 3/4 inch wall instead of a solid wall. But through some testing we found, and it's crazy, but through some testing we found that the permeability goes down when you have loose sand on the inside of that core. So I don't know, as the mold or the core is trying to breathe, if the loose particles fill the pores of the sand and make it less permeable.
Hmm.
But we did some testing a long time ago with our solid permeability pucks versus some that were shelled down to a certain wall thickness, and um, the ones that were solid
I
had
suspect
better
that's probably because
permeability.
all the loose
So
sand is run through the
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 tidbit of
recoater,
information.
and so it's got acid on it already, right? So 100% of the sand has the acid binder on it, which is the second part of the furan system. the first part is what the printer head is,
Yep.
the ink or the glue that it's putting down, and then the recoder comes across. So all that has it in there. It's probably because it's got a little bit of that material on there, the acid, to activate it. So I would suspect if it was just raw sand, it probably wouldn't have that permeability issue in my opinion.
So we always based it. We always, our theory. We're not experts by any means, but our theory was that the sand particles would actually uh, move around and plug the pores of the core. Since the sand particles are loose, um, uh, they can move and end up plugging everything. I guess plugging it up, which reduces the permeability. But I
With
don't know
that
if
being
that's the
said,
case or not.
there are some things that you can do to mitigate that as well. I mean, I had a job that I needed you to do. We couldn't make it in shell core; it was too small, so it was just a completely solid core. And then the other thing is, we had a core print on it that we couldn't. In the past, we couldn't get the core. It was like 3/16 of an inch in diameter, so it was had a very high tendency to want to break, and then the core would float, and it would scrap the casting. So what we did was the workaround for it that came up with was we would shell it out so we could get the core gas out of the cast or out of the core because it was completely encapsulated in metal, and then where we had that 3/16 pin on it, we would actually made a core print that went inside of the core that we would put a hardened steel pin in it so that it would help support it, and we could just put a little bit of glue on that. Do you remember that job, Todd?
Oh, yep,
So we were able to get the
yep,
sand out because we could
yep.
dump the sand out of it as shell, and then it would allow the
So
core gas
yeah,
to come out because we had two problems. We had the core breaking and floating, and then the other thing was we could fix that problem, but then with the core not being shelled out and it being solid, then we get core gas. We had to eliminate two issues when we were pouring that casting, and that was the solution. It doesn't solve 100% of the problem 100% of the time, but our success rate was a whole lot better doing that. And the only way we could do that without having some very expensive tooling made was to 3D print it, and it was super convenient.
I say, and that's the nice thing with 3D printing because yeah, we can print pockets inside of the cores if you want to drop a chill in. We can print a pocket if you want to put a reinforcing wire or something in it. We can run vents through impeller vanes that you normally couldn't do. Um, to help with that outgassing. So there's a lot of fun stuff, a lot of little cheats that we can do with 3D sand printing that you can't do as easily with
Sure, and
traditional
even to that point,
methods.
when you were saying that you could print it, you could hollow it out, and you could put sand in it. But a lot of times you could still do that. Give it, let's say, a 3/4 inch. So let's say it's a large aluminum casting, and you're having a hard time with this big chunk of sand in the middle of the casting. It doesn't get enough heat in there, and you're just having to chip that out of there, and then you're in danger of actually poking the casting with a chipping gun and damaging it, and having to repair that at the surface. But you could actually print it where you could actually leave a hole where you could actually dump the sand out of it, even if it's a big core. You figure out how to get the sand out of it, and then 3D print a puck that you could glue back on there. So it is hollow, so it will go ahead and collapse down with the heat and still solve that problem as well. I mean, those are little tips and tricks that the Foundry guys, and I'm not the only one, obviously, and a lot of Foundry guys are pretty inventive fellas, so it's pretty cool.
So yeah, as I say, and we've done that in the past. You put a plug in the end of it or whatever, or if it's not in an area, the core print goes out to an area where you don't worry about filling with metal. You can just leave it open to the world. But I've heard it prevents stress cracks or cracks and or tears and hot tears and castings as well. So there's some kind of neat things that we can do. But and that's and I'll say it again. I've said it before. We're not the Foundry experts. We don't pour anything, and so we rely on the Foundry to tell us maybe some of the issues that they're having, or tell us in some cases why they do things the way they do, and that just helps us be better when it comes to designing molds and cores to send out to somebody.
Sure.
So do you guys, I assume, let's just say I'm a guy who I need a part cast, and I've designed it in my CAD system. I know what it needs to be. I send you a CAD file. I would guess, right? Is that kind of how it works? And then, um, how does it work from that process for that place forward? I mean, I don't know anything about casting, right? I just know I need a part that looks like this.
Sure.
And do you work with the foundry then to develop a gating system, a venting system, whatever? Do you just do that on your own? How does that end up working?
Yeah. So, whether you send us a model, casting model or somebody else does, the first thing, somebody may send us a machine model. So, we'll work with them to remove any holes and add extra machine stock and then add whatever shrink rate the foundry tells us they need. We'll link up with the foundry. We love using teams. We'll link up with the foundry to look at the casting and talk through and figure out what they want to do for gating. And we can model that up right there on the teams meeting if we want to, or maybe the foundry takes a look at it and sends us a paper sketch or something like that. But we can model it up from there. And then we'll design the mold package along with the core. And then again, we'll link up with the foundry to take a look at it and make sure, kind of show them how it goes together, how it works, make sure that they're good with it and they don't see any issues. And then at that point, once they're happy with it, that's when we send it to the software for the printers and and we go ahead and get it printed. So, and it varies. We have customers that send us, a machine model or a casting model. We have some customers that send us a casting model with the gating on it, and then all we have to do is finish out the mold. We have some customers that send us the entire mold package. And
Is
so
once you've got a mold modeled, um, does the customer own that model or do you own that? How do you do that?
the customer owns the model.
Okay.
So, if they ask for it back, we can send it to them. But
And
yeah,
so
it's the customers.
they could send you one that's foundry ready, right? With all the gating and
Yes.
everything on it. Okay.
Yep.
Yep.
So, and that's the thing. And even if we get a mold that is quote unquote ready to print, we don't catch everything, but we do try to make sure that, we try to look at it to make sure that we don't see any issues with it. If it has a core, does the core fit? Does the mold go together? If we get something, a mold that we look at and think, I don't think we're going to be able to clean this, or I don't think you're going to be able to clean it, we try to point it out. And
Mhm.
there's times where we'll give recommendations. Maybe you design the core this way, and it'll make it easier or something like that. So, we can't catch everything, but we definitely try to the best that we can look it over to make sure that uh, when it's printed, it's
And
right
it
and it'll work.
certainly helps. I mean, that they have caught stuff that we have missed. You get busy and you miss something, so it's really nice to have you got pattern nerds on the other end that are really looking at stuff, and it makes a difference because not everybody is a pattern guy or gal. So it's huge for them to be able to think that way, and it's super helpful. So it's a service. It's one of those things that it's a cost of doing business, and yeah, it's super helpful, and it's something that you guys should hang your hat on for sure because it's saved my bacon more than once, and I hate to even admit that I make a mistake, but it has happened.
Now, my background wasn't in the foundry industry. My background, I am a mechanical engineer. I have an MET degree, and I was in the fiberglass industry for 13 years before I came to Hoosier Pattern. And so coming to Hoosier Pattern, I was familiar with 3D modeling, not familiar with the software that Hoosier Pattern used. So, there was a learning curve trying to figure that out. And then about a year after I started is when we got into the 3D sand printing. And so, I'm trying to learn the tool, what the tools are and how they work with the foundry industry, because, that was all kind of Greek to me at the time. But I think one of the things that probably helped the most, that I love doing and probably enjoy the most is getting to link up with the foundries and talking to guys like Nate and working through issues like this, because that's how I learn the most. These guys do it every day. They're familiar with it, and they're really good about when you're modeling something up. The talking to it and explaining why they're doing it the way they're doing it or whatever. And so feel like I learned a lot just by being able to talk to the Foundry
Yeah, it's
guys.
super important.
Yeah.
So
That seems like it's pretty rare that you learn anything from a Foundry guy.
you just have to find the right one.
You got to find the right
Nate's a
one.
Well,
good
I
one.
appreciate that, Todd.
Nate's
We
a good
try
one.
we try really
Yeah,
hard.
I'll
So
vouch for Nate.
and again, we've said this before. It's kind of a theme on the podcast. You know, being a learner. I mean, not everybody are learners. Somebody just come in and punch the clock, and they don't give a rip one way or another whether they learn something or not. They just show up to get a paycheck and do as little work as
Yeah.
possible. But those are the people that typically aren't long term on your team. And so being a lifetime learner, man, it makes your life, it's a lot more fun because it's not the same mundane crap every day. And you would think working in a foundry that you'd be there for 3 months and man, you got this thing figured out. And I guarantee you, I've been doing this for almost 31 years and I still learn stuff all the time.
You know, it's funny you say that, Nate, because that again, I mean, I keep talking about these recurring themes, but we're talking about people coming into this business, coming into the manufacturing world, or coming into the foundry world specifically. But this idea of learning and applying yourself and the opportunities that get created because of that. You know, it's not just a job. If any industry you get into, if your job is to go in and punch the clock and go home and punch and be done, you're not going to last. You're not going to achieve anything. You're going to be unhappy. But when you apply yourself and you start learning and you start learning to be able to do new things and develop new skills, keeps everything interesting, makes you a better employee. And I think it's going to also just increases employee longevity, by a lot.
I have three adult children now, but a couple of them are graduating from school, and that's something that I'm trying to kind of ingrain in them. He has a good job, but I just keep trying to tell him, do everything you can to learn as much as you can. I mean, you're going to help yourself out. You're going to help whoever you work for out too. But always being interested or being willing to learn new things is you can't go wrong. You really can't.
So Todd, we started off this whole conversation talking about your website and talking about your employee sort of spotlights and things and the environment within the company for the employees. But does Hoosier Pattern have any sort of a philosophy for their customers? I mean, what do you guys get up in the morning thinking you're going to do for your customers?
We the philosophy, and I think it's been ingrained into us from the start. We want to be very customer focused. We want to make sure that we have good relationships with the customers that we work with, and we want to make sure that the understanding is that when we produce something, we want to be known for quality. It doesn't do us, and that goes on the tooling side or the sand printing side. It doesn't do us any good to ship a tool out to turn around and have to have it come back and make changes because there's something wrong with it. We kind of pride ourselves on when we send it out, it works the first time. And same way on the printed sand side. We want to make sure that if we're shipping something out that has our name on it, we want to make sure that to the best of our ability, that it arrives to your place safely and that it works, and you get a successful pour and you get a good casting because we're all human. Things happen. I would love to say I've never made a mistake, but I've made a mistake a time or two. You printed and shipped a mold that it had the runner system, but it didn't have gating contacts.
I've only
just
made
one,
one
Nate?
mistake in my life.
But we want to.
Hey,
And that's because
we
you
won't
thought
get
you made a
into it,
mistake.
Todd. We don't have to air all my dirty laundry, pal. Good Lord.
That was the one mistake.
This isn't a podcast about me.
No, yeah. But
you're holding up your finger.
That's very
like,
true, Perry.
Look at me, I'm Nate.
Touche, buddy. Touche. Well, and I can testify to that. Yeah,
but
Sorry.
no,
and you
we
and
we
certainly
want to
are.
be known for
We
quality.
buy lots of mold packages. We've gotten them from more than one service bureau, 4 or 5 different service bureaus, and I can say that my dealings with Hoosier, my dealings with Todd and the team have been nothing but really, really good. They're still on top of things. Sometimes Jim's annoying as all get out because he's asking, hey, hey, we need this, we need this, but he's only doing his job. And you know what? I need that because I get so busy. And I'm picking on Jim. Use whoever's name, but they do a great job to keep things moving because again, we all get busy, right? And the name of the game, especially for me, so I appreciate it when he does that because the name of the game is get it done. Lead time, lead time, lead time. So anytime you're working on that, our customers depend on that. So I get busy just like everybody else. I drop the ball on something and then just, oh, God, there's Jim. I forgot about freaking Jim. And so I jump on it and we get it taken care of and linked up and knock it out. Even if I'm driving down the road, we've linked up and while we're checking teams and checking a model and that sort of thing. So I can say that the quality of the parts come out of there. I know that the print heads for those machines, they're very, very expensive and they go out because of the nature of them running a print head across an abrasive material like the sand. And they go out, they wear out, and you're going to get some issues there. But I have not, I can say I have never gotten a mold core package from Hoosier that I can recall that ever had issues like some of the other places. So the quality of that, I mean, speaks volumes. And I don't know how many years we've been buying mold packages from you, Todd, but it's been a long, long time. And the way they come packaged, everything else, as long as the silly truck lines don't destroy it on the way, it usually shows up just fine.
So Nate, you did mention something that spurred my memory, and this has been years ago. I don't know if you remember this or not, but kind of the same situation. Working on a mold package, and I think I gave you a call, and you answered the phone, and you were
Yeah, I
out
was
on
on a,
your
I was on a,
bike on a
I was on
bike
a,
ride.
I do
But you
remember
answered
that
the
because I
phone
was
and
riding with my,
answered
my
my
good
questions
friend
as
in
you
the
were.
neighborhood, Tom Sessions, and we were on a 6 hour bike ride training for Ironman Texas. And actually, if it hadn't been for Tom Sessions, I probably wouldn't have made it to the finish line of that race. And I may not have made it to the starting line for that matter. But yeah, it was a 6 hour session. We had just started. We were maybe 45 minutes into that ride. But yeah, I remember that call for sure. Yep. There's not very many
So,
times that you call me that I won't answer the phone, and that's almost any time of day, especially if it has to do with business. I get the side eye from my wife a lot, and honestly, I shouldn't be on my phone as much as I am. It's a I will say that I am addicted to the stupid smartphones and all of that sort of thing. I get an email and it pops up. We're going through the grocery store last night, and of course I'm there spending time with her going through the grocery store. I kind of enjoy doing that, but then she's looking at me like, "What are you doing on your phone?" And I'm like, she didn't say anything, because she's just sweet, but. I hate those stupid things. I wish we could just turn them off and stick them in a bin and do away with it. But I have to say, I am probably need to go to Phones Anonymous or whatever you want to call it because it's ridiculous. But I digress. You can chop that right out of this podcast,
Well,
Perry.
old people like me, we don't have that problem. Yeah,
On the
just
editing
consider it cut,
floor.
right? All right. Um, anything else before we say goodbye?
I
Well, do,
can't think
do
of
you
anything
want to
else
do
right
you want to
now,
let the people
unless,
know
unless
how
you
they
have
can
more
reach you
questions about the
guys?
sand
Do
printing
they get
side
a
of it.
hold of the Additive Manufacturing? Is there a certain email or phone number, or how do they get in contact with you guys?
Sure. One of the easiest ways is to go to our website, and I know there's a button on the website for submitting a quote. So, you can put your contact information in there. The best thing is if you can give us a little bit of a description as to what you're looking for. But if you have a CAD model or prints or something, you can upload them right there on the website. Um, you can also reach out to our team. I think if it goes to quotes at HoosierPattern.com, there's a number of us that are copied on it, so that if I'm out of the office or somebody else is out of the office, there's always multiple people that can see it come in and be able to jump on it. And you can reach out directly to me. email address is todd@hoosierpattern.com. I can't get much easier than that, and I'll take a look at it and get back to you with a quote. So we're
Yep.
pretty accessible. We try to stay on top of it. Try to get quotes turned around pretty fast. Of course, it is dependent on what happens to be going on right then. Workload permitting. Sometimes things just kind of get crazy busy, and we try to get stuff out as quick as we can. But
Agreed.
there's not enough hours in the day sometimes.
Makes sense. Well, that's because you're
I feel like there's
retired,
too many
Perry.
in a day.
Oh,
That's
that's
because I'm
horse
doing
crap.
nothing with my time all day long. All right. Well, Todd, thank you
Sorry.
so much. Yeah. Todd, thank you so much for being with us today. I appreciate it. I know it's Friday afternoon where you're at, and probably interested in heading to the weekend. So thank you. Thank you again for your time. We will put all your information there down in the description, and we'll see if anybody gets hold of you.
Well, hey, thank you guys. It was my privilege. Really enjoyed getting to talk to both of you, and excited about what you're doing with this podcast. I think it's a very, very neat thing. So
Cool.
You bet.
thank you for
You have
giving
a
me
great
the
weekend, pal.
opportunity.
See you,
Well,
Perry.
thank you.